Welcome back to Grundo Gazette. A few months ago, we announced that in the course of producing the docuseries Can Forsse Come Dream With Me Tonight, there was a lot of material that wouldn't make it into the final cut. Grundo Gazette is proud to be the platform to make as much of that content as possible available to you all. Today, we start that journey with a piece of video that has long been sought after by talking toy enthusiasts, called Teddy Ruxpin Inside Out. This video was commonly found on DVD through eBay at the turn of the millennium, but has since disappeared and can be very difficult to find in its original form. It was contributed by former Worlds of Wonder employee Stan Hanel. Stan was a colleague of the beloved Dr. Bearwell, who was the heart and soul of Worlds of Wonder's Grundo General Hospital, where many children's teddies went to be repaired. Stan has given us his permission to present Teddy Ruxpin Inside Out in its entirety. In the video, Stan walks us through the anatomy of Teddy Ruxpin and discusses some of the mechanisms that help bring the toy to life. Stan also takes some time to discuss the differences between the many versions of Teddy Ruxpin as the toy was refined and simplified over the years. In the video, Stan helps us diagnose two of the most common problems Teddy Ruxpin owners are likely to encounter over the years: a worn-out drive belt and a stuck servo motor. He then shows us, step by step, how to disassemble Teddy and replace the parts necessary to bring him back to life. These days, it's common to find many video tutorials online discussing how to repair Teddy Ruxpin and his friends, and we have an entire thread on our forums dedicated to some of the best resources available. However, this is an important piece of Teddy Ruxpin's online history, and it's a great jumping off point for anybody looking to keep their friends talking for years to come. Grundo Gazette would like to extend its deepest gratitude to Stan for his permission to share this guide with all of you today, as well as all of his contributions to the docuseries. In doing so, he has helped keep Teddy's stories alive for fans all over the world. And now, Grundo Gazette is proud to present Teddy Ruxpin Inside Out.
Welcome to Worlds of Wonder's Teddy Ruxpin, the world's first talking animatronic toy who was a hit of the 1985 Christmas toy season. We'd like to take you on a journey through the inner workings of Teddy, and we call our videotape Teddy Ruxpin Inside Out.
Come dream with me tonight. Hi, my name is Teddy Ruxpin. Can you and I be friends? I really enjoy talking to people. I would like you to meet some of my other friends too. We're going to have lots of good times together. Now, listen to this sound. That sound reminds you to open the book to page 1. Each time you hear that sound again, you turn a page, okay? There's a picture of Grubby. He's been a good friend of mine for a long time. Say hello to our new friend, Grubby.
Oh, hi there. How are you?
Remember, turn the page. Hey, Grubby, do you remember this song?
Yeah, I sure do.
Your friend is what I like to be. Your friend, 'cause I like you, do you like me?
Hi, welcome to the world of Teddy Ruxpin and Grubby and all their animagic friends, brought to you by a toy company called Worlds of Wonder that existed from 1984 to 1991. The company was very prolific and did some groundbreaking work in shrinking Disney's animagic or animatronic technology into toy size. These toys are now collector's items because the company was short-lived and because of the rareness of the technology and the ability to keep it working after 15 years now. These are still valued on eBay and other online auction and collectible toy shows. Basically, we'd like to go through the repair of Teddy Ruxpin to begin with and talk about the underlying animagic technology and what can be done to keep these toys running year after year and through all their ups and downs. The first thing I'd like to start with is Teddy himself, talking a little bit about his origins and also the founding of the company. Ken Forsse was an Imagineer with Disney back in the 1960s and 70s. He worked on Abraham Lincoln talking statue for the Disney theme park in California and Anaheim. He also worked on the rides It's a Small World, Country Bear Jamboree, and Pirates of the Caribbean. Teddy was inspired by Country Bear Jamboree when Ken was babysitting one night and tried to come up with an idea of a toy that would entertain children at bedtime, as well as kind of keep their interest. So his attempt to do this, he looked at Disney's technology and found an inexpensive, less expensive way to create it. These toys, he later partnered with a man from who had been a vice president of marketing at an Atari video game company, created a company called Worlds of Wonder, based on this animagic technology. In themselves, a lot of care and love was done in the design of these toys and manufacture to ensure a quality look and feel to the toys. Originally when they came out, they sold for about $60 each. These two work together, as you saw. There's a cable that interconnects them, and the sound can bounce between either the two speakers so the characters can talk back and forth, or the sound can be routed through both at the same time when they sing. What is beautiful to me is not only the outer plush look and design and the action and the synchronicity of the motors, but what's on the inside as well. And as you get into repairing your teddies and working more with the technology, you find that there's some really detailed, intricate mechanisms, motors, and control systems that make Teddy do his state-of-the-art magic. The technology, once you take apart and see the intricacy of it, is something that is not around today. It was very expensive to do this back in the 1980s. Originally, when Ken Forsse designed his first prototype and shopped it around to U.S. vendors, it was going to cost $150 just to make the toy. He was able to partner with Don Kingsborough and have it made overseas in Korea, Taiwan, and Hong Kong, and got the price down to about $50 per toy by using cheaper labor. These were marketed at around $60 a piece, plus there were lots of accessories that went with it too. Basically, the product line was grown from there to encompass not only these two characters, but a Mother Goose and Hector, a talking Mickey Mouse and Goofy pair, and Snoopy. The first time Snoopy ever talked, the production for Snoopy was done by Lee Mendelsohn, who worked with Charles Schultz to create the animated cartoon series. And all the characters are based on this animagic technology that uses specially designed servo motors, these here, to move up and down the mouth and the eyes on the characters. Some of the characters have turning head functions, as well as Snoopy has ears that move up and down as well. Basically, the beauty of the design is its simplicity. It's also a spring-loaded mechanism so that children could come up and wiggle the nose and move the mouth and the eyes. And ideally, because it's a synchronized servo motor, it would reset itself and continue talking right after they played with it. So it was designed with a lot of thought in mind. You'll see some of the flaws in the design as we look through a repair procedure, but for its time and even today, it's still a state-of-the-art mechanism that's you still only see most of the times in theme parts. Just to make these, there's so many parts inside that it's very hard to duplicate these characters today. So anyway, let's get to it. We're going to work on a Teddy. Ruxpin here, this guy here, and this just came in, brought him in from my storage, and we're going to take him apart, first test him to see how he's working, and then we'll dissect him and perform surgery and give you a tour through his inner workings and into his head, and we'll try and repair anything along the way that we see needs preventative maintenance, as well as the ones that need maintenance right now. So anyway, let's start with the batteries. The first place we start with Teddy is his battery box. This is his power supply, and this is basically what keeps Teddy powered and fully charged. He runs off of 4 C cells, and basically there's a little guide as to the polarity of those C cells and how they're going to be inserted into the battery box. Normally with Teddy, basically it shows a negative side on the battery and the plus side here. The negative side of a C cell is the flat side here. The plus side is the one with the nub here. And it even says it sometimes on a lot of the batteries, like this Energizer one here. The best batteries to use for all the Animagic toys are alkaline batteries. They give better life to the motors. They can handle more current than standard C-cell batteries. And just from experience, we seem to prefer Energizer over Duracell. We notice they seem to be a little bit longer sustaining for the motors. They don't seem to run down quite as quick, although Duracell batteries will give more current initially. Energizers seem to have a more steadier current flow, so we prefer them for a little bit longer life, although they're pretty close, pretty competitive. So we insert our batteries into here, and we take our test tape. This is called the Airship that we were just playing. It's the first tape in the series of tapes that came with Teddy and Grubby. Basically there were about 40 tapes altogether, and they were specially coded. As you can see, Teddy has a standard tape player, as you would see in a regular audio tape player on your cassette deck or that sort of thing. It has something called a read-write head, and that's this little silver magnetic read head in the center of the tape player, and that actually has 2 heads in one. Basically, your typical stereo cassette tape has 2 tracks on it, one for left stereo, one for right stereo. The beauty of the Animagic technology that Ken Forsse came up with is that he was able to use one of those tracks for the normal audio. When he engineered the tapes, he brought in people that did the voices for the different characters and had them tell the story and narrate it. And then to lay down the second track, he came in and brought in some puppeteers using special devices called Waldos that basically would make motion as they listened to the sound of the voiceover artist. Basically, the 2 signals would get merged together, and instead of a left and right stereo channel, you'd have the audio on one track and synchronized motor control pulses on the other. This would be fed through your tape head, and then there's a printed circuit board inside that we'll see that decodes those signals and drives the servo motors inside Teddy's head. Very sophisticated technology. Toy technology up until that time had just basically been unsynchronized. A toy would, like a pull-string toy, would say some words, and the mouth of the toy would just move up and down randomly until it stopped speaking. But here, with Teddy, what was breakthrough technology was that everything was synchronized. So when he held a note when he was singing, the mouth would raise up just a little extra. And so the beauty of these toys, the art is in that engineering and that synchronization and that audio animatronics. So to get started, here's Teddy's volume control and the switch. This is what turns him on and also controls the volume of his speech. So it's a rotary knob, and there's a little indicator here. It's sort of like a triangle. It starts at a low point, and then the triangle widens as you turn to the right. So basically, to switch on, you turn it clockwise, and then put it up. So right now I check to see if Teddy's tape motor is moving. Right now it's not, so that tells me I've got a problem with this tape player. This is a pretty traditional problem with most of the Worlds of Wonder characters we see 15 years later that have tape decks in them. Basically, for the most part, what's happened, there's two things. There's a little thing called a pulley belt that wraps around the main drive motor, and this belt basically gets stretched over time. Even if Teddy hasn't been used, because this motor's belt is under tension, just like the fan belt on a car, that sort of thing, it's going to be stretched, and over time, because it's such a small belt, it'll decay, the rubber will break down, and that's one common problem with them. So we know that's, right off the bat, we've got a problem. We're going to have to change out that belt. So let's get to work. I'm going to turn him off and pull out the batteries. This is his battery cover. Battery cover door has two metal pieces on it that basically maintain continuity between the batteries as you put the cover on. Okay, I pull out the tape from the tape deck, and I'll set that to the side. Some of the tools of the trade you're going to need to do this repair and do surgery on Teddy is a basic Phillips screwdriver, hopefully about a medium duty Phillips head, and that's so you can, it has to be narrow enough that you can reach inside. There's two screws here, Phillips head screws, that are inside Teddy right next to the volume control here. Other tools that you'll be needing are ideally a hot melt glue gun. I use a heat shrink or a heat gun for shrink tubing applications if I'm doing wire repairs. You'll need diagonal cutters for cutting wire. Ideally a needle nose pliers for bending or manipulating wire. It's a little heavier duty pair of cutters. This is solder for my soldering iron that I have over here. And here's some shrink tubing, some tinier screwdrivers if I need them. This is some unsoldering tools. This is a little vacuum pump unsolder for pulling solder off of printed circuit boards or unsoldering wires from connectors. And this is another way of unsoldering. It's called solder wick. And it's just basically a braid of copper that soaks up solder, sort of like a sponge, and it wicks up sort of like a candle wick, the solder, and then you just clip off each end as you soak up the solder to pull it off of something. I also have some nice little specialty tools that also are used in the medical field, some forceps to kind of grip on things and lock onto them and hold them while I'm playing with certain things. And then also like a dental probe to go in with. Sometimes this is helpful in trying to get into one of Teddy's motors or one of the other characters' motors by being able to reach in through the head and kind of start it up and work it that way without being able, if I can't get my fingers inside something. Really handy. Although all these tools aren't necessary, a lot of repairs can be done just with a screwdriver and mechanical devices. They do come in handy for almost any unexpected thing that comes along. And there will be broken wires, different things that do need to be soldered. So if you have some soldering skills, those are real handy. Another thing that's very valuable in testing batteries or continuity through wires or components themselves is something called a multimeter. This is a very old one. It's an old analog style. Basically it comes with two test leads on it, and this is for checking wires, that sort of thing. You can get newer ones from Radio Shack or other vendors that have digital readouts as well. They'll actually tell you the numbers for the volts that you're measuring or the continuity. scale as well. I happen to prefer this as one I've had for a long time, and it helps me spot things really quickly. Okay, we have undone the 4 screws on Teddy. There's 2 by the volume control that are in sort of a recessed cavity here, and there's 2 that are right under the battery door cover. These are a lot smaller, and for my screws I usually try and keep them in one location. I'll put them in a plastic bag or something like that, make sure I don't lose them. Another thing I've done is I'll keep a little box full of spare screws. If I've taken apart 2 Teddies to make one, I'll keep the extra screws and put them in a box and accumulate one over time that I'll have extra pieces of parts in. So that's always handy. Now to get to the tape player, basically we're just going to kind of pry up on the corners and pull them out. There's some tabs under the plastic that kind of hold the tape player on, but I'll need to just break those free. So I just grab the corner kind of at the top, pull out the bottom, and then we see on the inside, here's my other screw here, is the insides of Teddy. And this is the art. This is of animatronics right here. Basically we showed you the tape player there, and the tape player, that read head we were talking about, there's 2 sets of channels. Those signals come in to this connector right here, to this printed circuit board. And as you can see, there's 2 cables, one for each set of signals. One signal is the audio signal that it's reading off the tape. That goes through an amplifier circuit and then back out to Teddy's speaker here to give him his voice, his sound. Basically the other one, the other signal, is a coded set of pulses that some of these chips on the board are going to interpret and use to drive these 3 servo motor cables that go back up into Teddy's head. So basically the design of those 2 things are what makes Teddy work together, and because the tape is moving and the tracks are synchronized together, that's how he's able to get that precision. Also, the ability to use servo motors gives him the ability to have a real fine motion, and also to make it a constant motion that'll constantly reset itself back to a certain point. Even if the motor gets shifted or moved, it'll return to that point. A basic difference between a servo motor and a regular motor is something called feedback. A regular motor, basically you put current and voltage across it and it just turns. Basically with the servo motor, it will, when you move it to a certain position, this little motor here has also a gearbox and a little shaft, and when you rotate this motor to a certain position, it'll turn a variable resistor that'll send 3 signals back to my PC board, and it'll tell it its relative location versus where it's supposed to be from the signals on the tape. It'll compare the 2 and try and make them match up so many times a second. So that's gives Teddy his accuracy and ability to synchronize to the audio that's coming through the player as well. The other feature on Teddy, in order to make him work with Grubby, is that there is a little thing called a interconnect cable, and this is the connector here. And the uniqueness about Teddy and Grubby is that there are 4 conductors on their special cable. You can recognize their special cable. It has 3 stripes on it. Each of the metal parts in between the stripes is the same as a wire, and as you can see, they're wired point to point. Basically, but these cables are very hard to find because they have 4 conductors on them rather than 3. Also, the spacing on these is different than your normal, what would be like an audio video 4-conductor plug. Let's see. So basically what happens is this connector plug gets plugged into this connector here that comes off of this board, part of the board here, and then is routed over to Grubby, and then the control signals besides controlling Teddy's 3 motors and his sound will also bounce the sound back and forth between Teddy and Grubby to have them talk back and forth, and also control the 3 servo motors in Grubby as well. So these decoding circuits are all actually controlling 6 servo motors between Teddy and Grubby. Time is, let's get started replacing the pulley belt. And what we do as part of our repair features, we were lucky enough to come across some Teddy Ruxpin tape decks and PC boards and plastic housings that had never been used. These were factory fresh. So that gave us the advantage of having brand new tape players that we could put into the ones we repair. Otherwise, you may have to rebuild your old one and look at the components and see how if they're corroded or used or damaged. Let's go to it, and I can show you some of the insides that you want to be careful of if you're rebuilding it. The first thing to do when you're pulling this bezel off is to make sure you number the different connectors so you know where they go after when you're replacing the rebuild tape player. So I usually just, for my numbering system, is to go left to right. I know these are the 3 servo motor drivers for Teddy, so I just number them left to right, 1, 2, and 3. You can also do similar conventions this way, just 4, 5, 6, 7, and 8. And then basically, I think that's, oh yeah, we have more over here. And then 9, 10, 11. So I just am walking around the board, numbering every one in order. Okay, so I pull off all these connectors. And these are what are called Molex connectors. They all have little things called spring clips in them, but the wires are crimped onto the spring clips, and when you press it against these little square pegs, the spring actually pushes against it. One thing to be careful of is if a connector feels loose or like it just falls off, especially these 2-pin connectors or 1-pin connector, then you may want to look inside and make sure that spring inside isn't compressed. If it is, you may not be making good contact with the pin, and that could be a potential problem. Okay. So, now that we've got the tape player and the PC board and the plastic housing disconnected, the next step is to remove the printed circuit board. And there are 1, 2, 3 screws to remove that. There's one. And again, I put all my screws kind of in the same location. If you want to categorize it, you can even make smaller groupings where you just keep all the PC boards screws in one location, your housing screws for Teddy in the other location. It makes it a little easier to go backwards when you're reinstalling. Okay, and then I also need to pull the connectors off like I did last time from the board, from the tape player interconnects. Okay, and that's my printed circuit board. Okay, I still have, on this particular 3-motor Teddy, with Teddy there were many versions of him from the point he was first brought into the world until the company did go out of business. What they were doing was to try and simplify the design and cut costs and make them more efficient. The very first Teddy Ruxpins, this one here, started with the metal tape player. Basically, it was what they call a metal bezel tape player. Some of the flaws in the design, though, of these early Teddys were that they didn't have an automatic battery shutoff. So that basically they'd play and the tape would run out, but the motor would keep driving and trying to keep running the tape. So there was no sensor to tell the printed circuit board that the tape had reached its end. So a lot of times if people forgot to turn off the power switch, the batteries would be drained because the motor was still trying to run. So basically over the years things got refined. They went from a metal tape player. Although we prefer the metal, we think that has the best sound quality of all the ones. The plastic models and the circuitry associated with them were much better as far as saving battery life, and also much simpler design. Didn't have as many moving parts. So these are good quality, and actually were called the top of the line teddies by the employees at the company. So my next step is to get to the tape player itself, and this particular version also has another PC board embedded in with the tape player. So this is going to be a little more complicated. I'm going to have to unsolder this from the tape player and then transplant it into my new. Now that we've removed the PC board, basically we have these loose cables here, and we want to remove the tape player that's tied to this plastic, what we call a plastic bezel, by 3 screws as well. And this particular screw over here also has a lock nut as well that's embedded inside the tape. So when we remove this screw, we want to kind of put our finger over that lock nut so that it doesn't fall out and we lose it, because it is a very tiny little piece. So I put my screwdriver in there and recess part, and pull that screw out. There's my screw, and let's see, my washer's right here. And it's embedded nicely in the tape player, so we'll get it. And then I have 2 others, one right at the top of this plastic bezel here. These are all kind of sort of like a wood screw. This one that had the washer is like a machine screw. This is sort of like a wood screw. It bites into the plastic. All these do the same here. And they're kind of self-tapping, self-threading screws that basically dig into the plastic as they make their connection. Some problems that occur is that if something has been screwed and unscrewed a couple times, like a wood screw, it may start to strip out the inside and not grip as well. The thing I've always done is to try and keep enough of a collection of these that if I do have that problem, I just go with a longer screw that can dig in further down and give me some extra bite. Or you can try going with a wider screw that'll burrow into the thicker to the wider outer wall. So there's a couple ways around that to do these repairs as well. Now I'm going to try and remove the tape deck, and the key to it is I want to keep this door part kind of folded up. I want to be able to pull the tape deck through this area. I still have this little piece with the Worlds of Wonder logo on it, so I want to try and get it out from under there without breaking it off and keep my tape player intact. So what I do is I kind of push up on that and push up on this at the same time. The bezel will flex a little bit, and then I push up with my left hand on the bottom and then just kind of pull it out this way. And there's my thing, and there's my problem. Here's the pulley belt. It should have been draped around the inside of this motor, and it should have been draped around the inside of that pulley, but it fell off somehow. So this is my problem. I'm also testing it, and I'm seeing that, oh, this is pretty flimsy. The rubber feels very dry and like it's going to break on me, spongy. So it doesn't have the newness or the strength that it should. So what I can at this point, I'm also inspecting my contacts. We were talking about the automatic battery shutoff technology. On these newer ones, this is the technology right here. These little 2 metal points here, as the motor turns, they open and close, just like the old points on a car distributor. But what they're doing is, by opening and closing, they're giving a little pulse to my processor board that's telling it that the motor is moving, and it sees that pulse. When this freezes and there is no pulse coming out of here, the processor circuitry reads it as the tape has come to an end and automatically turns itself off by basically disabling itself at that point. The problem with that is if this belt gets loose to the point where, as this motor spins, as the motor in here spins, the pulley belt isn't turning these gears and causing those points to open and close, then the signals aren't going through here, and the tape player, the processor board reads the tape player as not working or the end of the tape, and as we saw, it didn't even get started. The tape player may start to turn. There's two other features that also are due to corrosion. As you can see, there's kind of a blackish material here, and a little bit over here. But these here, I would either try and clean those points by taking like an emery board or something to them to make them shinier and make them have a better contact, or I would replace the whole tape player altogether. And since I have a good stock of brand new ones, that's normally what I do when we're running our business. This particular contact here is engaged when tape is put into Teddy. What it does is it closes these 2 points together to tell that a tape has been loaded. When a tape is released, the door is lifted, and then when the door is lifted, it pushes down on this lever, which lifts this thing up, and there's a little spring that causes it to catch, opening up these contacts. And then these contacts down here, as you can see, there's like a two-way switch. Normally these are closed until this little lever is pushed down. Then it opens this contact but closes this one here. And this little device here is used in the bottom of the tape player to disable Teddy's audio animatronic function if a regular audio tape is put in. If you look at Teddy's special tapes, there are these tabs as in a normal tape, but there's also two little tabs in the center, and they use those as kind of a guide. When this goes into the tape player, if those tabs are there, the little spring we were looking at, the little switch here, stays in its normally closed position, and the little tab there falls into the hole and doesn't move. If you to disable the motor motion as the audio tape is playing, so you'll get the sound on Teddy, but the motors will not move. You'll just get audio sound. So that way you can use Teddy as a Walkman, a walk bear, I guess, and play audio tapes, but his motors won't randomly move around depending on whatever signals are coming out of the second track on that cassette tape. So anyway, that's what that switch is for, and the resulting electronics. We finished up disassembling the tape player, and we inspected the tape player assembly and looked at areas where we can repair that and rebuild it. The next step is to look at Teddy's inside Teddy's head. We're going to perform some head surgery here and take a look at his in this case, three servo motors that activate Teddy's eyes, nose, and mouth. Fortunately, Worlds of Wonder, the designers of it, made it pretty easy for us. They basically put a single seam up the back of Teddy that allows us to enter into that area. So basically, the location of that seam is right at the end of where the red cloth connects to Teddy's fur. You basically come with a seam ripper or a cutter or some kind of knife and just cut the little knot or a couple of the seams, and then hopefully basically the seam just opens up for you. Trim a little bit here. And then from there, if it's not too tight, you can just basically pull on it, the seam, loosen the seam, and then just pull Teddy's head all the way up to the end here, and then pull the wire, the thread out. And this is just one length of thread that started at the top, and there's a kind of a zigzag pattern that goes back and forth, hides the seam, and pulls Teddy's head together all the way down to the bottom here where it's sewn together, and then tucked into this ridge along Teddy's shell. And then when we press the bezel assembly in there, this will normally hold the Teddy's cloth outfit in shape there. So let's get into the head. Basically, we fold back the fur, and this reveals Teddy's insides, including this plastic mask that makes a strong plastic frame inside where the facial area is. There's a foam covering for Teddy's servo motors that makes it soft and prevents his motors from getting damaged. And that we can either peel off. That's glued to the top of this. We can peel that off or leave it in place. But to remove the mask part, there's two tabs that kind of clip on here and one on the bottom. So we just kind of push back this way and then push at the bottom and then pull his mask forward, trying to leave the nose and mouth together to reveal the motor frame that we showed you before. There's Teddy, there's his mask. And the way this was built is pretty ingenious. The legs and everything are attached to the body, but the upper outfit with the torso just slides right over the legs and comes off this way. So here's Teddy's lower legs with the fur glued to his foam, and then here's Teddy's facial fur, his body, and his arm fur in one unit also. Here we have two examples of Teddy's head motor, servo motor frame assemblies. Teddy, as he was revised and simplified over time, over 3 years from 1984 to 87, he went from a 3-motor subassembly, where you can see 3 servo motors driving 3 separate eyes, nose, and mouth, to a 2-motor subassembly, where you have 1 motor driving the lower mouth, and that lower mouth is hinged to the upper mouth, so as you drive the upper one, it moves right in mirror image, and then another motor for the eyes. The basic motor assembly, as we mentioned before, is spring-loaded. So as a child grabs one of these motors, that motor-attached facial features, the motor will automatically reset the motion of Teddy. And that's accomplished by the servo motor itself and this spring that keeps pushing it into place and automatically seeking the position that's generated by the synchronization signals on the tape. So I'm just going to pull a servo motor out just to show how it fits into this motor housing. I remove the spring. There's 2 little nubs in the motor frame, and then on the motor itself, this spring comes out from there. And then to get the motor out of the frame, I'm going to use my Phillips, the point of it. There's a little dimple on where this slot is, and then just push it out. All the motors are routed through Teddy's neck assembly, and that's just kind of a rubber stem, a square channel for putting the wires through, and that's held down with these clips. There's a clip here for holding the stem up to the motor frame, and there's another clip, you can see it right here, for holding Teddy's neck to the base of his plastic body here. So basically, once I remove the clips, then I can remove this channel for Teddy's wire motors, and then this one just has a little piece of tape on it. Just clip that. And open the channel up, and that gives me the freedom to release the motor. Now these are the key, these servo motors are the key to Teddy's operation. As we mentioned before, the difference between a regular motor and a servo motor is the concept of feedback. As a normal motor turns, it just spins in one direction or the other. We can reverse it forward or backwards. With the servo motor, you can get a lot more precise motion. And so basically, as Teddy moves back and forth, you can find an exact location for that motor. And if for some reason it changes, that motion is fed back to my printed circuit board here. And it tries to constantly readjust itself to the proper position. That gives Teddy real precise movement when he's speaking, and since it's synchronized with the audio with his voice, gives a realism that isn't seen in normal toys. And that was Teddy was a breakthrough product in 1985 when he came out. He was the big Christmas toy of the season because of this precision and lifelike ability to really portray emotion with just 3 motors like this, or even 2. One thing to look for in servo motors is over time there is a little motor here, a gearbox, and the feedback pot. There's also some grease inside that gearbox that can harden up during cold weather or become real liquid during hot weather. And what happens when it hardens up, it may freeze up the gearbox. A lot of the problems that result from a frozen gearbox or grease that is hardened in the gearbox is that the motor will just freeze and lock up. The motor will try and turn, but the gearbox is frozen, so it can't move very well. And so one of the solutions to that kind of problem is to just give it a good twist. Basically exercise that gearbox. If the grease hasn't been used for a while, by moving it back and forth, sometimes that's just enough to liquefy that grease that was kind of in a hardened state and get those gears kind of meshing together and moving. And that's enough to get that motor starting. Basically, as you can see with the eyes here, as this motor moves back and forth, the eyes move with it. There's a little cam on each of these features. It's like a crescent moon, and it meshes thanks to the spring being pushed against it. This rounded rubber cam on the motor shaft rubs against this nylon plastic cam, and that's what creates your movement. Sometimes if the motor locks up, you can work Teddy's eyes without opening them up and basically backdrive that motor. So what you're doing is making the thing work in reverse. And if you can get this cam to push against this cam and move your motor a little bit, that might be just enough to free up that gearbox and get it working without having to do surgery and open Teddy's head. We've tried that on several and have been successful maybe, 30 or 40% of the time. And the same with Teddy's other features. While Teddy, usually I try and run a cassette tape, and then while Teddy's talking and supposedly getting the signals to energize his motors, I can try working his external features, backdrive that motor, and then sometimes I can get those eyes to move, or the nose, or the mouth. But if not, then I have to do surgery and go in and either physically work that motor to get it going again while he's talking, or maybe replace the motor altogether. So it's good to have an extra supply of Teddy's to pull spare parts from if you need to. These motors aren't made anymore in this type of assembly, so about the only way you can get spare parts is to take one Teddy, an extra Teddy that maybe is broken in some way, and use the extra motors there to make your other Teddies work. So that's one approach. We do sell a limited supply of parts through our company, and can help you with obtaining parts. We can also provide the new what we call bezel assemblies, or the sub-assemblies with the plastic cover, the tape player, and the printed circuit board, if you would like to purchase those as well. Another thing to inspect when you're looking at the motor frame, look for any breakage. A lot of times we've found these motor frames are cracked right at the joint part. So if these things are broken, it's a good idea to just replace the whole frame. You can try super gluing a cracked part, but a lot of times that doesn't hold up very well. This plastic has aged over about 15 years now, and it becomes soft and brittle over time. So a lot of times if there is a crack in the frame anywhere along it, you probably want to try and replace the whole frame if you can. Another thing to look for, if there's slippage in these features, look at your cam, and if there's dirt or buildup on that, clean that off with alcohol. And a lot of times that'll become sticky, and it'll leave a residue at the point where this rubber cam meets this nylon cam. And when that happens, Teddy's mouth may not move as well, or just stick a lot more. So look in and clean that area. Basically, when your motor fails, it'll usually fail in 2 ways. Usually the motor itself will be fine, but the gearbox will either become very hard to turn. That means there's very little grease left in there, and the nylon gears are breaking, or they're cracked, or the grease has become too liquefied, or there's also a little tiny pulley belt in here that might be stretched, and you can tell when you turn this, you get a feel that it's slipping too much. The gearbox itself is too loose. The other thing to watch for is sometimes the gear grease can ooze through the holes where the feedback potentiometer is at, and actually coat the potentiometer and make it difficult for it to tell its relative position. At that point, then you need to replace the whole motor, because this feedback potentiometer is bad. Also, this potentiometer can wear down in time. By rubbing back and forth over time, it can become defective as well. So those are about 4 or 5 different failure modes. What usually happens with Teddy is either his eyes or mouth or nose won't work at all, or you'll get a chattering motion they call servoing. That's where the potentiometer is seeking to match up the point that the tape is telling it to what it actually sees from the motor, and it's not quite seeing it. Because the potentiometer is damaged, it'll kind of range back and forth. So you'll see Teddy's mouth just kind of jittering up and down, and usually that means you need to replace the whole motor. Okay, so anyway, we'll go ahead and start putting Teddy back together. Just in general, other general points to look at. One other frequent failure is the volume control switch that we were talking about earlier. It's the switch that turns on Teddy and also increases and decreases the volume. This switch is also, it's a rotary switch that has 5 positions, but it's also what they call a potentiometer. There's a little wiper contact that basically goes across each of these points. And as you can see, this particular one has some corrosion on it too. Normally, the switch part, this little crescent moon at the top of the switch gets pushed up by this little fiberglass piece, and that should lift this contact and separate it. And then when you go the other way and release that piece, it should contact this point here. A lot of times if this gets corroded, it'll never complete that contact, so you either have to again file that contact to make them nice and clean, or replace these part altogether. We do have extras of these, or sometimes you can find these in electronic parts stores as well. These problem that results from this switch and internal wearing or corrosion on the contacts inside is a staticky noise that comes from Teddy's audio signal. If you press on the volume control and it sounds staticky, or just in general there's a low-level static noise there, it's due to some corrosion on the internal parts of these contacts. At that point, you need to replace this as well. Again, another source, if you can't find it in electronics surplus store, is to pull one off a second Teddy and inspect the contacts and try replacing it, resoldering this onto the existing Teddy. In addition, speaking about the audio section, this is your speaker and your speaker cabinet. You might want to check if you're having audio problems with the speaker itself, and look at the wiring to that speaker. Usually there's a 2-wire cable, usually it's an orange one, with 2 pins on it that are soldered to the connection into the speaker. There's also a technique you can use with an ohm meter to actually measure across the impedance of the speaker. This should be an 8 ohm speaker. You can actually measure across it using your ohm meter, and when you apply the ohm meter across the 2 points, you should get a crackly sound from your speaker to tell if the speaker is working. So if you have audio problems, that's a good place to check. Another place to check, another source of potential problems with the battery cavity here is compression on these springs, battery springs. For some reason, your batteries are good and you plug them in, and it doesn't seem like you're getting any power to the tape deck or anything. check the compression on these springs inside. A lot of times, a couple of versions of Teddy used a flimsier spring, and it would get pushed in to the point where it was almost flat. If you have to, bend them back out and test for the compression of that spring. If it seems like it's going to cave in pretty easily, then you might want to see if you can replace that spring from another Teddy, or we have extras of these as well. So now we're at the point where we kind of want to reassemble our Teddy. If we had problems with the motors, we would replace them. I'm going to reinsert, as an example, reinsert this one into the frame. As you can see, I've got my notch in my frame and my motor that has this kind of ridge on it. There's a couple different kinds of motors. There's what we call the left-handed and the right-handed. On one version of the motor, the notch is to the left and your motor is on this side as you look straight down on it. On my other motor, the one in this frame here, my motor is on the left-hand side, and the notch part, as you can see here, is on my right. So you want to differentiate between those two motors when you're replacing one to make sure you've got the right kind and it goes right in the right, back in the right area. I think for the 3-motor Teddies, there's 2 of one kind and 1 of the other. For the 2-motor Teddies, there's 1 of each. So basically, to place this back into the motor frame, I try and line this up. I know my cam is here for my mouth feature. I know my roller is here, so I want to line this up so that it goes back in here. And then when I reseat it also, I want the nub from this motor to line up with the nub on my motor frame so I can put my spring back in. So I basically line this up with my notch, and there's a little kind of a catch notch in the center here that aligns with a kind of a raised piece in the center of my ridge here. So I've got to kind of push it so it'll hop that ridge and lock itself in place. Kind of push it in there, and I can use my screwdriver again. I like to use my Phillips with the little dimple in the ridge here and use that to push it in. Make sure I get the cam out of the way. And that sits really nice. It should just snap into place and be solid. And then I should also, because of the feature with the spring, it should kind of rock up and down a little bit. You can see how that engages the cam here. See how that rubber wheel on the end of my motor shaft kind of rocks and rolls in there. And then I want to put my spring back in. Make sure I can find my spring. Okay. I've got this lined up here. My 2 nubs are facing each other, and this is where my forceps comes in real handy, or you could use a needle nose pliers. But basically I want to kind of grip the spring, about maybe 3/4 of the way up, just grab onto one layer of the spring, and I want to compress it against one side, but hold it long enough so that I can get it over this nub as well. And that helps it fall back in place. A lot of times I tried to put these on with just my finger and my hand, and I get the thing compressed, and before I could get it over that nub, it would pop off and fly halfway across the room. So basically the forceps helped me position it, hold it while I was trying to get it over that top nub while I was compressing it. And the benefit of that is that it just lets you hang on to it easier. I've tried to do this with just my fingers, and a lot of times, just as I was getting it over the nub, the thing would pop off and fly halfway across the room, and I'd lose the spring, and I'd have to try and put another one. So these forceps or needle nose pliers make the job a lot easier in that effort. Okay, so basically the next step is to place the next stem on Teddy, and so I've got this channel here. It's a rubber channel. I tuck my wires in and put this over fold the wires inside there. Try not to pinch any wires, and then fold this channel up. As you can see, there's kind of two sides to this channel. There's one that has like two cross pieces here, and one that just has one cross piece. I usually try and put the two cross pieces up toward the top of the head, and the single cross piece down at the base of the neck. And then to seat it, I want to kind of also secure this extra flap. I'm going to tape it just to hold it, but sometimes it's a lot easier if I just press that part in against where I've got three sides surrounding it. And then to hold it in place, these plastic clips go back in on either side. They press in, and then they latch on the other side. There's two little kind of hook ends that grab around the plastic to lock it in. That's not going anywhere. Then this part inserts back into through my neck. There's a rectangular cutout there. I slide that in, and then put another clip to latch this to my body here. And then this comes through the body and then connects to my PC board from there. That's my head sub-assembly. The other part of Teddy's motor frame and facial features to be concerned about is looking at the facial parts themselves, the eyes, nose, and lower mouth. Basically, those usually are the most prone to breakage from kids or whoever plays with Teddy. As we were saying, they're built to take a certain amount of abuse, where you can they expected kids to kind of grab them and work them back and forth while Teddy was talking. But a lot of times in play, kids are a little more aggressive than that, and things get damaged beyond repair. And especially at the point where after 10, 15 years now, the plastic is starting to where it's getting soft or brittle and breaking more easily. So you see a lot more teddies that have broken mouths or broken eyes. You can replace those to an extent. Sometimes at the factory they glued these things in place, but like the motors, they're mounted on inside grooves on the motor frame, and if the glue isn't very strong, you can slide those things in and out. So here's basically what those individual parts look like, and the resultant tab that would slide into the motor frame assembly. That's the nose. Here's your lower mouth, and there's the tab there. You can see the cams built into each feature so that the motor can work against it. And the eyes are kind of unique. They have a cam, but they also come in two pieces. So they come apart like this. If it's broken, it's hard to replace that. You can try re-gluing them, but ideally your cam, this is actually a three-piece system. Your cam slides into this part of the eye. So that would be your left eye. And then, as you can see, there's two grooves. One is the cam shaft. The other is a long groove. The hole goes through the cam. So basically, you insert those two in there. And this also goes through two holes in Teddy's area here. But you insert it in the motor frame through two holes in the motor frame. And then this just joins together like that. And then you have to make sure the holes, those two rods, pass all the way through the holes on the other side, and that gives you Teddy's motor eye movement as well. And then the workage, when the motor works against the cam, that makes his eyes move up and down. Okay, let's start putting Teddy back together. This is the rebuilt tape player. As we saw when we pulled out the original, the belt had fallen off, the pulse points were corroded, my tape insertion contact points were corroded, and then I think there was some corrosion on here as well. We replaced this with a brand new tape player that had never been used before. It also has a brand new reed head that has never been used, and a new roller that has not been damaged or hardened. So that's when we do our repairs, we have access to these special factory fresh tape players that were never opened or used. And then in addition, we'll replace this pulley belt that was on the module that we pull from out of its bubble wrap, and we actually replace this with a new fresh one, because we found that even after even though it's been sealed, never used, this belt has been under tension, so the original one that's on this factory fresh tape player still may be bad, and so we go ahead and replace it with a new one anyway. And then in addition, because of I transplanted the PC board that was on the original, and I basically had to unsolder this from my original board and solder it back into these connecting points on this board. So I had to do that and make it work. But what I got is a nice cleaner module that should give me another 2 to 5 years worth of work without any more problems of corrosion for it. Basically, if you don't have access to a brand new tape player, then cleaning those contacts will probably get you through, and then see if you can find a replacement belt for these. We use a PRB line of pulley belts, and there's certain ones that you can match up that are close to this, and there may be some electronic supply stores in your area that carry that. There's other pulley belt line manufacturers as well, or if you want to contact us, we can get ones for you directly that are exactly the right size. Let's start putting it back together. We'll go just the opposite of how we started when we took Teddy apart. Insert my tape player in so that my tape cable, the reed head cable, goes in first, and then these other 3 cables come in behind. In order to do that, I'll need to pull my plastic cover out and to the back, but I still want to keep it at an angle, so I want it to kind of be back this way so I can get that in. I lead with my tape cable, and then I want to kind of slide the thing so it goes between these 2 points here. So I'm going to push up on that with my fingers and try and fold the motor in, and I also want to get these connectors to go in through this hole here. It's a little tricky at first, takes some practice, but the more you do it, the easier it gets. You may have to try it a couple times to get it in there. Basically. So basically, I make sure my 3 connectors clear the bottom without getting jammed inside on this side, and then I've got my 1 connector up here that comes off the tape head. That's up at the top here, and then I want to kind of line up there's 3 holes in here, and make sure those line up and that everything's seated well, so I don't have anything that's just in there cantilever. I can double check where the mounts, the screw mounts go, make sure they line up well with the holes. And then to seat it, I'll go ahead and do the opposite of what I did earlier. I have my 3 screws plus the nut for the tape player. There's a recessed little area in the tape player where the nut goes. I'm going to put that in first and hold it down with this finger while I flip it over. And then I find the screw that's a machine screw, not a self-tapping screw, and that's what goes in on this side. Make sure I seat that. Tighten that down, and I make sure that my the threads from my threaded screw don't go beyond the edge of that, or if they do, very little, so that when my tape goes in, it's not being punctured by the end of that screw there. So then I try and find my next one. Take my 2 threaded screws. One goes in the top, and one goes in the bottom. Bottom quarter, bottom right hand quarter. Okay, we've mounted the cassette player inside the plastic housing, or what we call plastic bezel. Now the trick is to mount the PC board on the plastic bezel and insert our connectors. This is the printed circuit board that was in Teddy. Over the years, Teddy evolved. There were several versions of this printed circuit board. This was one. If you look on the board itself, there'll be, and you hold it this way, there's a little thing that says REV. That's short for revision number. Early ones had just a REV with a dash after it. Those were in the very early versions. This particular one that I try and use now is the Revision E board, or Rev E. It's the latest version that was put out of those 3-motor Teddy Ruxpin boards. You can tell it has 3 connectors on the side, but it also has the latest features for basically sensing when the battery is, being able to turn itself off automatically when it senses the tape is at the end and all that. So if I'm swapping boards or I have several Teddys, I want to make sure that the revision number on that board matches the one I'm replacing it with. Basically, here, as you can see, this is a version of a 2-motor Teddy printed circuit board. And instead of the 3 connectors on the side, this board's been simplified where there's only 2 connectors that are used to drive the 2 servo motors in Teddy's heads. Also, you can see there's fewer connectors around the peripheral. There's just they've eliminated about 2 or 3 connectors that are on the original board too, to simplify this particular Teddy Ruxpin. That was the last of the large-size Teddys, the 2-motor version that came out about 1987 or so. So to seat this board, we take our 3 screws that we removed originally and reseat them in the bezel. Here's the 3 screws back in position there, and I'll go ahead and reseat my connectors. This one coming off the tape head goes to here, to this area. This connector, this is wraps around kind of in this channel here, goes over to the end here. I have another one here that's my power. Goes to here. Or actually, that's my pulse counter to make sure the tape's moving. And this particular one goes over here. So if I've numbered these correctly, they should fall back into place. Otherwise, if you do enough of these, you start to figure out what connectors go to what mating pin there. Okay. Now I want to reattach Teddy back together and remount this back into the speaker cabinet, as well as put Teddy's costume back on. So let's start with the costume. Tuck his legs through the bottom 2 holes. And then he's already got his arms attached, so the key now is just getting the head on. I try and primp his mouth and his nose together so they'll slide through the mask. Here's the mask here, and as we said before, there's 3 clips that are going to clip around positions on his motor frame. So I want to slide the nose through and then try and make it so that these clips line up and snap into place. Then I fold the skin over the foam rubber and try and bring his cloth body, his clothes over the foam as well. this gets Teddy ready for sewing. And at this point, we can either try and sew his head back on, or I like to just test Teddy first to make sure everything's working before we sew him back together, so I don't have to redo it. So I'm going to go ahead and reinsert the tape player bezel assembly here first. And again, if I've numbered everything correctly, I should know where these are going. This is the switch volume control, goes to the top here. And my speaker goes right next to it, this connector. On the bottom of the board, I've got my, this is actually my power, this 2-pin connector here, or 1 pin. And then next to it is the output port that goes to Grubby or to the answer box or the movie show projector. And then all that's left are my 3 eyes, nose, and mouth connectors for the servo motors. So if I've got those numbered right, I definitely want to make sure I match up the numbers, because otherwise Teddy's eyes will move when his mouth is supposed to, and we don't want that to happen. Let's see, there's, I've got the number 3 here on the bottom. You can kind of tell too by the lengths. Usually the short one, because it's coming from the top part of the motor chassis, will be the topmost one. Let's put those all together, and then ideally when I reseat everything, the wires and all this, back in the cabin, I want to make sure I'm not pinching any wires. So as we saw, there's like an area here especially is kind of critical, where the door hinge assembly rests. As this opens and closes, this these 2 half-moon brackets push that thing up, and that's critical to, so that when the tape deck opens, the little sensor in there is activated as well. So I want to make sure when I press it in that basically everything clicks into place. There's no pinched wires, anything like that, and that basically Teddy's switch is free to move, that I didn't pinch any wires or push that in the wrong way. And then to test it, I can, at this point, screw things in and button it down so I can test it, or I just make sure I press real hard and put my batteries in. And again, I follow the procedure that shows me on the battery card. I've got my 4 C cells. It shows me the plus side, which is the nub, negative side up. So, and then on this particular battery box, I alternate them. Negative plus, plus to negative. And then I make sure my battery cover is clean. I've got 2 strips on that tie all those batteries together. One thing that often happens is these get corroded as well, or batteries leak, and you get like a greenish battery acid, and that'll keep this from making good contact. I want to make sure those are clean. And then I'll go ahead and put in my test tape, turn them on, and see if it works.
Gimmick. But everyone just calls me Gimmick. I'm an inventor. Oh, yes, indeed. We discovered that Gimmick is a marvelous inventor. Oh, I think marvelous inventor might be exaggerating. It would probably be sufficient to say wonderful inventor.
We also discovered that Gimmick is modest.
We told Gimmick that we were on a journey to find a treasure.
Looks like he's working. Now, if I'm pretty much convinced he's working, I'll go ahead and sew up the head and then button him down for good. My wife Marianne is doing the sewing on Teddy's head. She says to use a ball needle upholstery thread to make sure the thread is long enough to do the sewing with one length. She has doubled the thread over here, and as you can see, she started underneath right at the top of the head and is doing kind of a back and forth stitch to try and pull the 2 halves of Teddy's head together in an even seam. She's going back and forth and carefully lining up the seams, pulling tight every three to four stitches to make sure the fur is closed with no thread showing. As you can see, Marianne finished up the seam by pulling it together every 3 or 4 stitches. She sewed it together really smoothly all the way to the end here. And then what we've done is tucked the fabric from Teddy's cloth body all the inside this reservoir, all around the edges of here. And now I'm going to reinsert the tape player bezel that I've reassembled, reconnected. And again, making sure all the wires are tucked away. They're not getting pinched under the door hinges here or back by the battery compartment. And then these tabs snap into place. And then again, I have 4 screws remaining. I've got 2 large ones that go inside the recessed channels here for the top of Teddy, and then 2 small ones that go down by the battery box. Drop those into the reservoir. Need my Phillips screwdriver, medium size, so I can get down inside the channels there. And just tighten down. These are the self-tapping screws. So if you have a problem, if they don't go in all the way or they feel like they're stripped out, you may need to use a longer screw or a slightly wider tapping screw in order to dig into the plastic. You want to make sure when you're doing the battery box that it connects flush with the connector point here, so there's no gap where the batteries should be springing up. Just make sure I press down real well. Sometimes if I don't tuck the fabric right, it can keep the plastic housing from going all the way in. So make sure I'm good there. Pull back a little bit. Kind of pull the fabric out just slightly while you're tucking it in. Okay, it lines up pretty good. Go ahead and install these. Okay, looks like we're ready to go. Reinsert our batteries according to the battery card. And then close the cover. Start them up. Volume control. Make sure the volume control moves freely.
Very interested. So we went to Kitty's house to see just what this new invention was. Yes, here it is. I call it an airship.
A lot of times when we get a grubby, or Teddy and Grubby and all his friends, we get to a spot where they've been soiled, or a child has fed them too much chocolate or something like that, where they need to be cleaned. We've got a lot of questions, and when we started, we were also interested in finding a good cleaner that would be strong and reliable for cleaning Teddy's fur, but also safe for children, so that it wouldn't have any chemicals or any other byproducts that could cause them to be ill or that sort of thing. We found this brand called Folex. It's pretty much available in a lot of hardware stores and grocery stores. Folex. It's made by Folex Company in Spring Valley, California. And the nice thing about it is it does seem to work pretty effectively. It's called an instant carpet spot remover. It's for cleaning carpets and spots on carpets. It says it removes pet accidents, grease, ink, red wine, coffee, blood, rust, food, cosmetics, dirt, most old stains, excellent for upholstery. It seems to have worked pretty well for us over the years. And again, the good part about it is it's safe. Basically, it's has no real toxic materials in it, so we've been able to use it very generously by either spraying it directly on the fur and wiping it with a white cloth, or for basically for just spot cleaning, where we can just spray a spot of the Folex on and just work on a certain part of Teddy. So both those techniques work really well. There are other carpet cleaning products out there that other people have used and are more comfortable with. Whatever works for you is good, but that's one that has helped with us over the years. So we thought we'd recommend that. That's the end of our repair tape on Teddy Ruxpin. We hope that you brought away some information that you can use to solve problems that you encounter when trying to get Teddies working normally, or over time if the nose or eyes or mouth or whatever jams up. There's certain techniques you can use to try and get them fixed, and that you feel comfortable going inside Teddy and looking around, see if you can find some problems, and then being able to sew him back together and get him back into one piece. If you have any questions, please call us or email us. Our email is, and we're available online for if you had any questions on our videotape and would like to correspond with more information. We also would like to thank you for your attention, and hope that we can be of service to you in the future in making Worlds of Wonder products more alive to you, bringing Animagic technology, keeping it going for years to come. Just to give you a preview of what we hope to be our future tapes in this series, we have a gallery of all the Worlds of Wonder products that used Animagic technology, and also a couple incarnations of Teddy that were created by Hasbro and Yes Entertainment, two licensees that later gave life to Teddy down the road. This is Worlds of Wonder's related products that came out after Teddy Ruxpin was a successful hit in 1984 to 85 Christmas season. The company itself lasted about 3 years before undergoing bankruptcy, but in that period they created a whole line of really imaginary and very complicated but beautiful products. Then the company came out of bankruptcy briefly in 1989, created a smaller version of Teddy Ruxpin, the Teddy Rux before going bankrupt in 1991. Hasbro picked up the license for Teddy and produced a version that was similar to the original by Worlds of Wonder, in the smaller version that lasted about 5 years, and then another company called Yes Entertainment produced a version of Teddy in the late 1990s before they went out of business also. So basically these are really quality toys and with good technology that's still ahead of its time. In addition to Grubby, Teddy also had other peripherals like this movie projector that could actually show his adventures on a wall, and then the answer box that was an interactive question teaching aid for children to teach numbers and colors and sizes. The answer box buttons would light up when Teddy would ask a question, and after a child would pick one of the answers from this overlay book, it would respond with affirmation as to the correct answer or correct the child if he was wrong. So anyway, some of the other toys in the Worlds of Wonder product line were Mother Goose and her friend Hector, and like Teddy and Grubby, they were a pair, and then Mickey Mouse and Goofy basically were paired together. Snoopy from Peanuts characters was created, and this was the only incarnation of Snoopy that approved by Charles Schulz that ever talked. Snoopy was to be paired with a Charlie Brown at the time, but the Worlds of Wonder company was having financial problems and chose not to create a Charlie Brown partner to Snoopy at the time. And in addition, the ultimate version of the Animagic technology was Julie, the talking doll. She also had voice recognition capabilities created by Texas Instruments and could recognize up to about 6 key words spoken by a child. Those words in turn would trigger her to use her Animagic technology to speak on a certain subject related to that key word. She also had a light sensor, sound sensor, motion sensor, and could read a book by touching these resistive contact spots with her 2 contacts on her hand. So the company was very prolific. It was a combination of Ken Forsse's Imagineering group from Alchemy 2 and a lot of good engineering from the Northern California, from Stanford University related people and former Atari game manufacturing people that really brought this magic technology to life. And even though the company was short-lived, the technology still has a lot of value, a lot of promise for the future. We hope to keep it going for many years to come. We hope you guys enjoy your efforts and get a chance to enjoy what was created here and the magic of that technology. Have fun, and thank you again for listening to our tape. Bye-bye.